And we're back in Chapter 11. In the last podcast, we were talking about writing out equations. We first started out with word equations, and then we moved into using chemical equations, where we're actually using symbols to show reactants and products. And in this podcast, we want to talk about balancing equations. According to the law of conservation of mass, matter is neither created nor destroyed, it only changes forms. During a chemical reaction, if you recall from Chapter 2 as well, atoms and molecules simply rearrange themselves. You don't bring in any new atoms, you don't lose any atoms, you simply rearrange them, similar to playing with Tinker Toys or Legos. And so you have to account for every single atom of every single element in a given equation. That means on the reactant side of the equation, you're going to have the exact same numbers and types of atoms as you would have on the product side of the equation. And so let's take a look at this particular reaction here. The first reaction where you have sodium metal, it's a solid, being placed in water, which is a liquid, and it's going to produce sodium hydroxide solution and hydrogen gas. The way you go about balancing these things is to simply count up each individual atom of each individual element. So the first element is sodium. We have one sodium atom on the reactant side, and if you look on the product side, I'm just going to go ahead and have a dividing line here. We also have one sodium. So far, everything is okay. When you take a look at the hydrogens, on the reactant side here, you have two hydrogens. On the product side, you have one hydrogen here, and you have two over here, so you have a total of three hydrogens over here on the product side. So in order to balance this, there's nothing, what we're going to end up doing is putting coefficients in front of the compounds to make sure that you have equal numbers of atoms. Now there's nothing I can put in front of any of these compounds to make the balancing work right now. So what I'm going to do, if I have an odd number, this is just a little strategy that I use, I like to even up odd numbers. So I'm going to put up a 2 in front of the sodium hydroxide. Now I cannot change the 2 in the water here to a 3 to make it balanced. H3O is not water, it's a different compound altogether. It's called hydronium. It also has a positive charge. That's illegal. You cannot change the subscripts of the compounds. You can only put numbers out in front to show that you have more than one molecule or more than one unit of any particular compound. So by putting a 2 in front of the sodium hydroxide, I now have 2 times 1 hydrogens in sodium hydroxide. So I have a total of 2 there, plus I still have the 2 with the hydrogen gas, so I no longer have 3. I now have, scratching that out, 4 hydrogens. Alright? When I put a 2 out in front of there, I now have 2 oxygens on that side of the equation as well. I have 2 times the 1 oxygen in that sodium hydroxide. Now when I put the 2 sodium hydroxides out there, what I really mean is I actually have 2 units of that. So I have NaOH and another NaOH. So you can think of it that way. Now, because I have now 4 hydrogens and 2 oxygens on the product side, I'm going to go back and I'm going to put a 2 out front of the water. That now gives me a total of 4. 2 times 2 is 4 hydrogens on the reactant side, and now I have 2 oxygens on the reactant side as well. When I put a 2 out in front of the NaOH, I now have a total of 2 sodiums on the product side. So I want to get 2 sodiums on the reactant side. And so now if we take a quick inventory, I have 2 sodiums on the reactant side, 2 sodiums on the product side. We're good there. I have a total of 4 hydrogens on the reactant side. I have a total of 4 hydrogens on the product side. So I'm good there. I have a total of 2 oxygens on the reactant side. I have a total of 2 oxygens on the product side. So now we're balanced. We have equal numbers of all elements on both the reactant and the product side. Bookkeeping this is a good way of starting out balancing equations. However, as you go, you stop bookkeeping those things just for ease. All right, moving on to the next one here. We have hydrogen gas reacting with oxygen gas to form water vapor. I have 2 hydrogens on the reactant side. I have 2 hydrogens on the product side, and so far we're good. I have 2 oxygens on the reactant side. I only have 1 oxygen on the product side, so I'm going to need to put a 2 out front. Now the oxygens are balanced. However, I have now thrown the hydrogens off because now I have a total of 4 hydrogens on the product side, so I need to come back and put a 2 out front. 2 times 2 gives me 4 hydrogens on the reactant side as well, and now the equation is balanced. 4 hydrogens and 2 oxygens on both the reactant and the product side. Alright, sliding down to the next reaction. The production of ammonia. You have nitrogen gas and hydrogen gas producing the ammonia. I have 2 nitrogens on the reactant side. I only have 1 nitrogen on the product side, so I'm going to put a 2 out front. I now have a total of 2 times 3 gives me 6 hydrogens on the product side, and I have only 2 hydrogens on the reactant side, so I'm going to put a 3 out front. So now I have 2 nitrogens and 6 hydrogens on both the reactant and the product side. Now this is also a good opportunity to show exactly what these coefficients mean. What this means is that I have 1 nitrogen. I'm just going to show you what this looks as a molecule. You don't have to know this. I have 1 nitrogen here. I have 3 hydrogens. Let me take that 3 out of there. I have 3 hydrogens that would look like this. And then I have, on the product side, I have 2 ammonias. Don't worry about what those dots mean if you're not sure what those are. That's okay. But all I want to show you is that on the reactant side you have 2 nitrogens. On the product side you have 2 nitrogens. On the reactant side you have 1, 2, 3, 4, 5, 6 hydrogens. On the product side I have 1, 2, 3, 4, 5, 6. What ends up happening is all of these bonds get broken, and you take 3 hydrogens and 1 nitrogen, and that's going to form one of the ammonias. The remaining 3 hydrogens and 1 nitrogen will form the other ammonia. So again, it's just like you're playing with Tinker Toys or Legos. Just break up the pieces, reassemble them. However, this balanced equation shows you how many of each compound you need to produce a certain number of product compounds. And sliding on down here, let's try the combustion of methane. I'm sorry, this would be propane. So on the reactant side, I have 3 carbons. On the product side, I only have 1 carbon, so I'm going to put a 3 out front. On the reactant side, I have 8 hydrogens. On the product side, I only have 2 hydrogens, so I'm going to put a 4 out front. 4 times 2 gives me the 8 hydrogens. On the reactant side, I have 2 oxygens. On the product side, I have 3 times 2 is 6 oxygens with the CO2. Plus, you have the 4 times 1, you have 4 oxygens there, so 6 plus the 4 oxygens gives us a total of 10 oxygens on the product side. So I need to get 10 oxygens on the reactant side. I'm going to put a 5 out front. That gives me 5 times 2, 10 oxygens. And now we have a balanced equation right here, where you have 1 propane will react with 5 oxygens to produce 3 molecules of carbon dioxide and 4 molecules of water vapor. Alright? We're going to stop this podcast here. In the next podcast, we're going to continue balancing equations.